hey. I don't know why I start like that every time. It's like I have nothing else to say but hey, and then whoa, and then hey, what's up? All right, whatever. My name is Mr. Krause, but for the next 20 or 30 minutes, you know me better as Mr. Key. So our website, you can go to algebra2commoncore.com, or you can just go to www.nkinfinity.com for all of our stuff. Yeah, that's where we're going. It's got a listing of all of the videos in order. You can just go to my YouTube channel if you want to, but NK, N stands for Newman. She's my partner in crime. You'll see a picture of her on our website. And K stands for Krause, or Mr. Key. And infinity is just because infinity's cool. I like infinity. Anyway, let's graph this. All right. Got a Y-intercept of -5, so it's got a translation down 5. So we're going to go down 5. That's about right there. Gosh, I hate when it does that. And then the slope, instead of being 1, is between 0 and 1, which means it's wider or less steep. So we're going to go up 1 to the right 3, up 1 to the right 3, up 1 to the right 3, so on and so forth, and such. Graph the line. There she be. That's what she be. All right. What is the equation? Well, it was shifted down 1, so I know it's going to be y equals, it's down 1, and it looks, wait, it's got a vertical, it's got a reflection in the x-axis because it's coming down, so I know it's negative. It's coming down. And let's see what its slope is. Down 2 and over 1. So it's down 2. Negative 2x minus 1. There it is. Oh my God, it was so much fun. I'm not even done with the first page. I was so excited. Compare the two graphs. Okay, so let's start. There's only two things we got to compare. We got to compare slope, and we got to compare y-intercepts. So, compare them. Okay. Wow, lots of different answers for these. I'm not going to write this out. I'm just going to talk you through it. If you have a negative slope, that means, so this one has a negative slope of a slope of -2, and the other one has a slope of 1/2. Now, which one has a higher rate of change? Slope and rate of change are the same thing. So which one has a higher rate of change? And in this case, this one does. -2. Now, even though it's negative, it still has a higher rate of change, which means it's going to be a steeper line. So this one is steeper than this one. This one is traveling down or decreasing. So this one is decreasing, while this one is increasing. This is decreasing at a higher rate than this one is increasing at. This one's only increasing at 1. This at a translation down 1. This had a translation up 3. And that's about what we wanted you to get out of that one. All right. So the parent function for the line for this, why did I not write? I wanted to write this. Well, the parent function for a line is y equals x. So we're just going to graph that in. That's the line. Oh my gosh, I got to put points, and I hate it, but I have to. So dink, 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 dink. So there's the line y equals x. Now remember, parent functions are graphs that have no transformations on them. There's no dilation, there's no reflection, there is no vertical or horizontal translation. I thought I'd turn that off. Twitter, gotta love it. All right. At the first break, I'll turn that off. As soon as I'm done with this problem, I will turn that off. You'll never do it again. My y-intercept is y equals 0. It's the origin. My slope is 1. My domain is all reals, left and right. My range is all reals. It goes up and down forever and ever and ever. Increasing, decreasing interval. Where is it increasing? It's increasing everywhere. Remember, when we're talking about increasing, we're talking about from left to right. So from left to right, this is increasing everywhere. So it's increasing from negative infinity to positive infinity. And its decreasing is an empty set. So if you're talking about increasing, we're talking about a rise. And we're talking about this, we're talking about a fall. Rising or falling, increasing or decreasing. Is it a function? Yes, of course it is a function, because it passes the VLT, the vertical line test. Is it a one-to-one function? Yes, it is, because it passes the VLT and the HLT, the vertical line test, and the horizontal line test. Don't forget, it's got to pass both. All right, I'll be back. I forgot to turn off my notifications. All right, I think they should be off now. We should not be having any ear interference off and away during the day. Turn your phone off. Oh my goodness. All right, let's move on to the next page. There's our website, Algebra 2 Common Core. You could also go to nkinfinity.com. Two different forms of a line. So you guys, and I say guys, I mean girls and boys and all you other kids in there that are girls and boys. Oh my God, it's so exciting to talk to you all. Anyway, I'm back. That was my alter ego. He comes in once in a while. He's a little weird. He's a lot weird. All right, slope-intercept. That's just y equals mx plus b. Why is it called slope? Because this is slope and this is intercept. Why is it called slope-intercept? This is the slope and this is the intercept. Now, you've done that a gajillion times. That's no big deal. Slope is m. So over here, this is called point slope form. Why is it called point slope form? Because you are given a slope and a point, and you're going to use this equation. The y, notice the y is just y. Always have to have a y in the equation, and always have to have an x in the equation. Now, so we'll have a y in the equation and an x in the equation, but the thing that we're going to use to figure out what the actual equation is are those 2 points. So, here's why you want to know point slope formula. Point slope formula, because here is a graph. I can't tell what the y-intercept is. I mean, it goes up and up forever and ever. Here somewhere, it's going to be up here somewhere. I'm going to guess. Let me guess. 18. I have no idea what it is, but it's up there somewhere. But I don't know. I mean, so how am I going to find it? If this is all I've been given, how am I going to find it? So let's see. I want to write the equation as line. So I'm going to use point slope. So I'm going to use this point right here. It looks like a nice point. That point is 1, 2, 3, 4, negative 4, 3. And the slope is what, and the rate of change is 3 and 1. So my slope is 3, and my point that I'm going to use is negative 4, 3. So I want to create the equation of this line given these two factors. All right, no problem. So we're going to use y minus y1 equals mx minus x1. So we plug in what we know, and what we know is, now remember that y and the x are the only thing that aren't going to change. Everything else is going to change. So we're going to do minus 3 equals 3 times x minus. Now remember, anytime you sub in using parentheses, punk. Yeah, I called you a punk. Because if you didn't, look what happened here. If you just put in x minus 4, and you go, oh, look, it's negative 4. Let me put in negative 4. But that's not really what it is. It's x minus negative 4, which makes it positive 4. So don't make that mistake, okay? So what we got here, now that we clean things up, is we got y minus 3 is equal to 3x plus 4. Distribute the 3. Woo, come up here. So I get y minus 3 is equal to 3x plus 12. I'll add the 3 over, and I get y equals 3x plus 15. So now I can tell what the y-intercept is. The y-intercept is 15. I was close. I said 18. I had no idea. This one here I might be able to actually tell. Let's see. It's going to be a fraction. It's not going to be nice. This one's not going to be nice. So let's see what we got here. We got this point right here. And we got this point right here. I like to pick the one that's got all the evens. They don't have evens. All right, so 1, 2, 3. 1, 2, 3, 4, 5. So that's the point 3, 5. Now my slope is 1 and 2. So the point I'm going to use is 3, 5. The slope, or my m value, is down 1 over 2. But wait a second, I said down. It's falling off. That means it's got to have a negative slope. All right, so we're going to use that formula. I'm just going to sub in y minus the y value equals slope negative 1/2. Oh, why did I just write a really weird looking 3? Negative 1/2 x minus 3. Oh, yeah, that's going to get ugly. So we get y minus 5 is equal to negative 1/2 x plus 3/2. Now I got to add 5. Add 5 to that. Well, this is really 1.5 and 6. So my equation is going to be y equals negative 1/2 x plus 6.5. Now that kind of makes sense. Plus 6.5. There's 5. There's 6. Yeah. If I drew that up there, it'd be about 6.5. That makes sense. All right. By the way, if you come here and... Oh, I'll finish my thought in just a second. I probably should have mentioned this, and I'm probably going to try to remember to say this more often so that when you come here, you notice what's going on. But I would not run like this in my class, just one problem after another problem after another. I might show you one or two and then say, okay, you try to do a problem on your own. You see what you can do. So, pause the video, try this one on your own. Can you come up with the equation? Most importantly, can you come up with the Y-intercept for this problem? All right, let's try this. Hit pause and then come back. Pause. I said hit pause. All right, you're back. Hey, you're back. That's so good. There's my point I'm going to use. Let's see. 1, 2, 3, 4, 1, 2, 3. So 4, negative 3. And my slope is up 3, and over 2. I was thinking about that too, and I wrote the 3. So it's going up 3 and over 2. So my point is 4, negative 3, and my slope is 3/2. I don't know why I wrote a parenthesis there. I should have wrote an equal sign. So I'm going to use the formula. Y minus, look at that, minus negative 3. So it's really y plus 3. By the way, your answer should be somewhere, maybe, let's see. That's 5, 6, 7, 8, 9, 10-ish, somewhere around there, maybe. I don't know. If you don't end up with negative 9 or negative 10, if you don't end up with negative 9 or negative 10, you did something stupid. Don't do it. So let's see what we got. Y minus 3. So 3/2 x minus 4. So this is y plus 3 equals, now 3/2 times x is just 3/2 x. 3/2 times 4 is minus 6. Subtract 3 from both sides, I get y equals 3 over 2x minus 9, because I subtracted 3. And that's about right. That's what we decided. There it is. Yay! Oh! It was fun. All right, point. Let's see. We're going to pick this point. Negative 6, negative 2. And the slope here is just 1. Well, that's kind of boring. So my slope is, wait a second, it's negative 1 because it's falling down. London Bridge is falling. And my point is negative 6, negative 2. All right, so we do y minus negative 2. All these negatives, I hate negatives. You got to be careful with them. Negative 1, x minus negative 6. So this becomes y plus 2. By the way, my answer should be 5, 6, 7, maybe 8, maybe negative 8, somewhere down here like negative 8. Not sure, but it should be close. Is equal to negative x plus, oh, wait a second. skipping steps here, kids. Can't do that. So I'm going to do -1 times x plus 6, because this became really a plus here. So what I end up with is y plus 2 equals -x minus 6. Subtract 2 and I get y equals -x plus, minus 8. Man, I need me some more coffee. I need to make a Dunkin' Donuts run. Maybe on the next break I'll make a Dunkin' Donuts run. -8. All right, I'll be back. All right. So all of this stuff is just transformations, just more and more and more transformations. Let's keep going. Rate of change over an interval. That should go away. So rate of change over an interval. So we already know rate of change stands for slope. An average rate of change would be the average of the slopes. Does that make sense? Well, I know my slope formula. Let me remind myself my slope formula. You know, your cool math teachers like to use fancy things like delta y over delta x, or in other words, change in y's minus change in x. Why do we always put x2 first? I don't even know. You just do it. It doesn't matter. As long as you stay consistent, you can do it any way you want. So determine the average rate of change for this. Well, this is a linear functions. Linear functions have a slope no matter where you are. That's always going to be a 0.8. So if I've got a line, let me just take you over here. If I have a line that has this as its slope, let's say this slope of this line was m equals 5. Well, the slope at this point is 5. 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 And the slope at this point, no matter where I go on that graph, the slope will be 5. So then I take my average, so I add them all up and divide by how many I got. So if you add a 5 plus 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 5 plus 5 plus, and just keep adding 5s up and then divide by how many 5s you added up, you'd end up with 5. So for a linear function, the average rate of change is just the slope. Now, I'm going to modify this equation. I forgot to. I need to modify this equation slightly. This is how we like to remember it, the change in y's over change in x's. But this can also be f of x2 minus f of x1. Now remember, this is really just y2, y1, all over x2 minus x1. That's another way to thinking about it. The functional value at the second point minus the functional value at the first point, all over the change in the x values. But for this particular case, we're going to find out this is just the slope. So we want to do it over this interval from 0 to 10. So we're going to find out what f of 0 is. Well, f of 0 is 1. And then f of 10, oh, sorry, you probably know, like, where did you get that from? So I plug in 0. 0.8 times 0 plus 1 is 1. F of 10 is 0.8 times 10 plus 1, which is 9. Okay, so here's what we do. Average rate of change. F2, f of x2, so that's 9, minus f of x1, which is 1, all over 10 minus 0. Okay, that's 8. I don't know why I have 2 equals. 8 over 10, which is 0.8. Oh, so that's just the slope. So for a linear function, the average rate of change is just the slope. So each day, Madeline records the height of a basil plant for her science lab. Oh, this is so exciting! It's real life, kids. Her data that she collected are shown below in the table. What is the average rate of change in height per day from the plan from day 1 to day 5? So what we're going to do is we're going to do h of 5 minus h of 1 all over 5 minus 1. So h of 5 is 8.9 minus h of 1, which is 3.0, all over 5 minus 1. So, 5 minus 1 is 4. I just doing a little bit of math ahead of myself. Okay, so this is 5.9 over 4. That's kind of boring. Let's go see what it looks like on our calculator. 5.9 divided by 4. 1.475. So my average rate of change is 1.475. Okay, there we go. During which interval is the average rate of change the greatest? Now I could go through, so I've got 3 intervals. I'm gonna highlight them in different colors. I need to get a different highlighter. Let me hold on. I'm gonna come back. I'm gonna have a different highlighter. Okay, I got a couple new things. Oh, all right. So what we're gonna look at is first we're gonna look at yellow. We're gonna look from -4 to 2. Well, here's from -4 to -2. Then we're gonna move from -2 to 2. And then we're gonna move from 2 to 4. So I could do this, and you're going to find this relatively annoying. Let me do this in orange. I could say we're going to do f at -2 minus f at -4 all over -2 minus -4. And f at -2 is -2. Minus -2 all over -2 plus 4. So this becomes 0 over 2, which is just 0. Now I could do that. I just use these 2 points, and I found the slope. But I could do that. Can't I just count? So I know from -4 to -2, my slope is 0. Now this one, on this line, I'm going up 1 over 1, up 1 over 1, up 1 over 1. So from -2 to 2, my slope is equal to 1. And then this final one, let me do some black down, coming down here. It's coming down. So first of all, I know my slope is negative. So from 2 to 4, I know my slope is going to be negative. And it's going down 2 and to the right 1. So that's -2 over 1 if we want. So the question says, during which interval is the average rate of change greatest? I'm not looking for the largest number. I'm looking for the one that has the largest or greatest average rate of change. And that would be this one. Even though it's -2, it's got the largest rate of change. Remember, we're looking for the one with the biggest number. Finish my answer key on this one. All righty, moving on. All right, so we did absolute values yesterday, so let's go back to them. Is this a function? Yes, it passes the vertical line test. Let me get into orange. Yes. Is it a one-to-one function? And by the way, it's because it passes the VLT. No, it is not, because it fails the HLT. Domain, it goes forever and ever to the left. It goes forever and ever to the right. Range, though, let's look at range. Range, the lowest value is down here. That's at -8. So the lowest value it's going to be is -8, and it goes up to positive infinity. X-Intercepts. Over here at -6 and +2. So I'll put those in set notation because they are 2 discrete points. That's a terrible set notation. Now, notice this just means the point -6, the point 2. Not from -6 to 2, the point. That's what the curly braces mean. The Y-intercept, there's only one answer. It's -4. I can put that in set notation too. Where is the graph increasing? Increasing just means where is it going up? And it starts increasing right here, and it goes increasing up and up and up and up and up here. But you can't include this point because at this point it's kind of like a transition point. It started coming down and then it went up. So at that point, it's neither increasing nor decreasing. So my interval would be from, and the other thing is when you're talking about intervals increasing and decreasing, I know my big fat head's in the way here, so let me move this over. You must only use X values. We want just the domain or the input values. So what this is really asking you over, what interval, what domain interval is the graph increasing? Well, it starts at -2, but not including -2, and goes on forever and ever increasing in that direction. Where is the graph decreasing? Well, you'll notice it's decreasing starting way over there somewhere, and it's decreasing, 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 decreasing until it gets to -2. So from -infinity to -2. I can't tell you how important it is that you understand. We're talking about X values. So from here over, it's decreasing. From here over, it's increasing. Now remember, we always read left to right. So as I'm reading from left to right, from -infinity all the way down to this point right here, it was decreasing. And at this point is a transition point, and we're going to turn and go up. Oh, where is Y? I might have to read these off my page here. Where is Y greater than 0? Remember, this means positive. Positive, let me erase all this stuff. Positive means above the x-axis. So if this is now my cutoff, positive, Y greater than, this is less than 0. Less than 0 means, this means negative. Where is Y, or where are the Y values negative? Let's, starting here and here, all of this. This is where it's negative. So from -6, notice I can't include -6 because at -6, it's 0, and 0 is neither positive nor negative. So from -6 all the way to 2, it's negative. Now, where is it positive? Well, it's positive starting here and going off in that direction. It's also positive. Now, by positive, we mean up here, up above the x-axis. So it's positive from -6 out. So that's either this direction or this direction. And because that's an or, we're going to need a union in the middle. So let me just put that union in the middle. Now let me just deal with this part. So from -6 all the way to -infinity. So remember, -infinity always has to go on the left. And you can't include -6 because it's 0. At -6, it's 0. And then also starting at 2 and going out to positive infinity. Starting out here at 2 and going to positive infinity. Remember, we're going to the right. It's positive. The next question says, where does it equal 0? Where does Y equal 0? Well, that's the same as asking where the X-intercepts. Well, I could do this. So that's at -6 and 2. Notice this is curly brackets. You can't use square brackets or parentheses because those represent interval notation, which means a continuous list. Set notation just means -6 and +2. Understand the difference. All right, I got to stop and I'll be right back. Okay, so increasing and decreasing, it deals with the X values. Min and max, that means the highest and the lowest. These deal with the, I wish I could go to the left more. Oh, I think I can. These two deal with the Y values. And you have to start making a note of which ones deal with this. Min and max this way, increasing, decreasing, we're going to talk about using the X values. So what is the minimum value of the graph? The lowest value of the graph is down here at Y equals -8. So -8, put that in curly brackets. I can write Y equals -8. What is the maximum value of the graph? Well, the maximum value of the graph is infinity. It goes on forever and ever and ever up, but doesn't stop. is the inverse a function? If you remember yesterday, in order for it to be a function, the graph has to pass the vertical and a horizontal line test, or it has to be one-to-one, and said no, and you could say not a one-to-one function. Therefore, inverse is not a function. I know that's behind my head. I apologize. All right, so let's talk about what this graph's going to look like. Okay, so we know it's an absolute value function. So let's start with that idea. Absolute value of x. So I have to decide, do I need a negative? I have to decide, do I need a number? I have to decide, did it move left or right? I have to decide, did it move up or down? So those are 4 things I have to decide on. The first 2 I'm going to decide on are these 2, because these are the vertex. We move to the left 2. Don't forget, when you move to the left, on the inside, that's backwards, plus 2. We move down 8. On the outside, it is exactly what you think, minus 8. It's going up, so there was no reflection, so I don't need anything in this yellow one. I don't need a negative, but it is a little bit steeper. It's up 2 over 1, up 2 over 1. So my number out front is 2. So my answer here is y equals 2 absolute value of x plus 2 minus 8. All right, let's keep going. Can't move this. All right. What is the equation of this line? Let me get to my red pen. What is the equation of this line? Let's see. It's got a y-intercept of 5 and a slope or rate of change of 3 over 1. So this is y equals 3x plus 5. Domain and range are the same. It goes up and up forever and ever and ever. It goes left and right forever and ever and ever. So the domain and range are the same. Negative infinity to positive infinity. Negative infinity to positive infinity. Sorry, I don't want you behind my big head. X-Intercepts. Wow, we got to kind of make that one up. Do we? We have to make that one up. Let's see. It's right here. What do I got to just make it up and make up a value of it? I don't know. Wait a second. How do I find the X-Intercepts? Probably should have given you more room there. X-Intercepts. Geez, that's really weird. So let's see. If this is the point, this is a point where, doesn't this point where y equals 0? Let me do that work off to the side here. So I know the equation is y equals 3x plus 5. And so I know that for an x-intercept, the y value has to be 0. So it seems like I would just have to solve this equation. Bring the 5 over, I get negative 5 equals 3x, and x equals negative 5 over 3. So that's a little, not quite negative 2. Let's see if that makes sense. Oh yeah, that makes not quite negative 2. So my x-intercept is x equals negative 5 over 3. Now y-intercept's easy. That's just y equals 5. Is the graph increasing or decreasing? It is increasing. I didn't need much room for this one. And the reason it's increasing is because it has a positive slope. Or it's rising from left to right, it's rising. All right, where is it greater than 0 and where is it less than 0? Remember, this means where is it negative, which is below the x-axis. This means where is it positive or above the x-axis. Well, here's the cutoff point. From here up, it's positive. Now remember, and from here down, it's negative. But we're really talking about the x value. So going in this direction here, it's positive. Going in this direction here, it's negative. So my answers are from negative infinity to negative 5 over 3, it is negative. From -5/3 to positive infinity, it is positive. I think I have two questions that somehow got on the other page. Where is y equal to 0, and is it a 1-to-1 function? So where does y equal 0? Y equals 0 at x equals -5/3. We know that one. And is it a 1-to-1 function? Yes, it passes the VLT and the HLT, kid. So it passes both, so yes, it is a 1-to-1 function. Okay, I'll be back. So I'm going to guess your teachers probably didn't get through all of this in class because there's a lot of work here. They probably got through that and then said, hey, go do these last two on your own. Maybe. I don't know. So let's see how quickly we can go through them. By the way, if you already know what you're doing, stop, pause the TV or pause the thing and go, excuse me. Go see if you can do it on your own. Excuse me. So yes, it's a function. It passes the VLT. Yet, no, it is not a 1-to-1 function because it fails the HLT. Domain, it goes forever and ever left, forever and ever right. Range is a little bit different. This is the highest point now. So remember, big point goes on the left, small point goes on the right. So remember, so this is the highest point, and the lowest point is down here at negative infinity. Okay, X-Intercepts, -2 and +2. Since they are two distinct points, we have to write them like this. Y-Intercept, just 2. Where is the graph increasing? Remember, for these, we're going to use X values. So, increasing. It's increasing. Remember, we're going to read from left to right. So, as we're going in this direction, it's getting bigger and bigger and bigger and bigger. So, from negative infinity to 0, it's increasing. Remember, we're using the X values. So, if I'm reading left to right, coming in this direction, it's going up until it gets to this point right here. And at this point, it's going down. So it's decreasing from 0 to positive infinity. Where is it negative? Well, let me highlight. It's negative whenever it is below the x-axis. So it is below the x-axis. That's why. Here. And here. So my answer to this question is, where is it negative? It's negative from negative infinity to 2. Union 2 to positive infinity. Notice I did not include the 2's because at 2 it's not positive or negative. It's 0. Oh, that's this one. -2, +2. Where is it positive? Well, it's positive in this area. From here to here, it's positive. So that's from -2 to 2. What's the minimum of this graph? It goes forever and ever and ever and ever down. So the minimum of this graph is negative infinity. What's the maximum of this graph? 2. And I can write y equals. Is the inverse of this graph a function? The answer is no, because not 1-to-1. In order for the inverse to be a function, it has to be a 1. In order for the inverse of this graph to be a function, it has to be a 1-to-1 function. 1-to-1 means the original and the inverse are both functions. And I want to write the equation of this thing. All right, so it's an absolute value. So let's just do it together. Let's just do this one. Okay. So it's an absolute value, so it's y equals. It's coming down, so I need a negative. It's got a slope of 1. This is, this up 1 over 1, so I don't need a number out front. It did not move left or right at all, so I don't need anything in here with the x. But it did move up 2, so +2. There it is. One more. Oh my God, I'm so excited. I had to stop for a second. Oh no, wait, no, we're back. Last problem for number 5, day 5. Okay, so we have to create the equation of this line. Line's easy. We're going to just point slope formula. So since it's right in front of us. So my y-intercept is +1. I'll just put that there. And I know my x is here. Now I also know it's going down, so it's going to be negative. And let's see, I use 2 points. This point and let's say this point. So it's going down to over 3. So down to and over 3. My phone just told me, or my watch just told me I've got to get up because I've been inactive all day. All right, domain, negative infinity to positive infinity. Range, negative infinity to positive infinity. It goes forever and ever left. It goes forever and ever right. X-intercept, it looks like it could be 1.5. I'm not really sure, but I do know that when the x-intercept is when y is equal to 0. So negative 2 over 3x plus 1. I'll bring this over to this side because I hate things that are negative. So I got 2 over 3x equals 1. If I multiply by the reciprocal, which is 3/2, I get x equals 3/2. Well, 3/2 is the same as 1.5. So my x-intercept, as I thought, was 1.5. My y-intercept is easy. It's just 1. Is the graph increasing or decreasing? It's decreasing because it has a negative slope. Or in other words, it's going down. It's always going down, or always going down, so it's decreasing. Where is y positive? Where is it above the x-axis? Well, it's above the x-axis, all of this. So from negative infinity all the way up to 1.5, it's negative. And then starting at 1.5, it becomes negative. Oops, excuse me. Pretend like you didn't see that. Where is it negative? It's negative starting here and going in this direction. See how it's below the x-axis? This means negative. So from 1.5 to infinity, it's negative. Where is it positive? It's positive up in this area. So it's positive from negative infinity to 1.5. Ooh, can you see that behind my big head? And finally, where does it equal 0? It equals 0 at x equals 1.5 or 3/2. And is it a one-to-one function? The answer is yes. Because the original function is a one-to-one function. It passes both the vertical and horizontal line test, and therefore it is a one-to-one function. And oh my gosh, man, it's so much fun. I've got to go. Time's up. Hit the like button, hit the subscribe button. Let me know if you need anything. Comments, you can leave comments. Please leave nice comments. I'm old and fragile and got a very sensitive heart. Getting old here, kids. Goodbye. Have fun storming the castle.